Math 7 Unit 2 Solving, Lesson 4, Part 1, Introduction to Solving, Properties of Equality. Okay, first let's take a look at what solving is. There's a couple ways to look at it. Solving is finding the value of an unknown number. For example, what number when multiplied by 2 gives 10? Now for that, you just kind of think about it for a moment. A number that you multiply by 2 and get 10, it'd have to be 5, right? You can also think of solving as getting the variable by itself. These are just different ways of looking at doing the same thing. For example, if we have 2 times a number plus 1 is 5, we can do things to make it so that that variable gets by itself. For example, subtracting 1, that'll make the 1 minus 1 become 0. And we're left with just 2x on one side. And then we can get rid of the 2 by turning it into a 1. 2 divided 2 is 1, so we divide both sides by 2. And we can get to the answer. So, solving is getting the variable by itself. Solving is also working backward. When you work backward, you are basically starting at the end and working your way back to the beginning. So for example, a number is doubled, then 3 is added. Last it is squared. The answer is 121. What was the original number? Since the last thing it did was square, we're going to unsquare first and get 11. So 121, the unsquared is 11 because 11 squared is 121. Then we're going to unadd 3. If you unadd 3, that's subtracting 3. That gets us back to 8. Then we're going to undouble. Undoubling something would be to take half of it. So the original number has to have been 4. So we can also think of solving as working backwards. And the thing we're doing backwards is the order of operations. Okay. This symbol right here is the equal sign. And the equal sign is used to demonstrate that two things, two quantities, two numbers, are equal. So think about what would fill in the blanks on here. 3 plus 6 equals blank plus 2 equals blank. Alright, there is a common error with this where students would believe that this fills in with 9 and this fills in with 11, but that is simply not true. An equal sign, it needs to be equal on both sides. So really 3 plus 6 will equal a blank plus 2 equals blank. Well, 3 plus 6, because this is 9, this needs to also be 9. So it's got to be a 7. So all three parts of this triple equation are equal to 9. And that is what is actually true here, is that when we add, we end up getting the same thing on both sides of the equation. So it is a common misuse of the equal sign in this sense. When you're using the equal sign, it needs to be equal on both sides. If you wanted to do 3 plus 6 and get 9, and then do something with that, maybe I'd add 2 down to get 11 so that it's not showing it this way. I could also have written it this way, 3 plus 6 equals 9. And then I'm going to start a new equation, kind of a new sentence. And I'm going to do 9 plus 2 to get 11. You can use the arrow to indicate next step, rather than trying to use the equal sign. The equal sign is only to be used to show that two quantities are equal. Okay, today's lesson we will be able to verify a solution to a linear equation, solve linear equations, justify each step in solving a linear equation, and model situations with linear equations. Okay, first, the equal sign. It's a symbol used to state that two expressions are equal, not an indication of the next step in a process. For that, use the arrow. For example, 3 equals 3 or 4 equals 3 plus 1. Equation. A mathematical statement containing an equal sign, a statement that two expressions are equivalent. For example, 0 equals 1 minus 1, 11 equals g squared plus 2g plus 12, y equals mx plus b. Those are all examples of equations. The important thing is that they do have an equal sign. An equal sign is what makes them an equation. Okay, open sentence. A mathematical statement that can be either true or false depending on the values used, as opposed to a true statement or a false statement. For example, a true statement is 5 equals 5. A false statement, -1 equals 4. And an open statement, x plus 1 equals 5. It's true if x is 4, but false otherwise. Solution. It's a value that makes an equation true. A solution is stated as a solution set. So a solution set is where we'll put the answer or answers within curly brackets. So in the examples, for x plus 1 is 3, the solution is x equals 2. And this has been put inside a solution set. Equivalent equation. Two or more equations that are considered equivalent equations, then the same value of the variable makes both or all equations true. For example, 3x equals 6 is equivalent to x equals 2 because the solution x equals 2 makes both equations true. Identity, last vocabulary word here, an operation that does not change the value of a number. An open statement, an open sentence that is true for all values of the variable. A do-nothing operation. Now there are 4 identities so far that a 7th grader should be familiar with. You need to know that adding 0 is a identity. A plus 0 equals A. You get at the end what you started with. Subtracting 0 is also an identity. B minus 0 is B. Multiplying by 1, 1 times C will equal C. Good. Dividing by 1, D divided by 1 is D. So all 4 of those things do nothing. There's the very special number 0 if we add or minus it, and there's the very special number 1 if we multiply or divide it. And those will give us the operations that are identities because they don't change the value of the equation on either side there. Okay, let's look at the additive identity. The additive identity is when we add and nothing changes. So 3 plus 0 is 3. 9 plus 0 is 9. -1 plus 0, -1. X plus 0, of course, will be x. Z plus 0 is z. And r plus 0 is r. The values do not end up changing. Okay. Also, you need to know how to get to a 0. -6 plus a number is 0. Remember that a number and its opposite add up to 0. So 6 and -6 make 0. 7 and -7 make 0. 0.5 and -0.5 will add to 0. -0.9 and +0.9 will add up to 0. 1/2 and -1/2. -3 halves and +3 halves. Those are all examples of numbers adding to 0. And these ideas that we're going over here with 0 are going to be really important in solving. So consider this true statement. 8 equals 8. If I decide to go ahead and add 2 to both sides, I will get 10 equals 10. So 8 plus 2 equals 8 plus 2. You get 10 equals 10. And that is also true. So when you multiply or add the same thing to both sides of an equation, if it was true before, it's true after. That's actually called the addition property of equality. Addition, because that's what I'm doing. And it is a property. A property is something that tends to hold for all situations of equality. It's the property of the equal sign. The same thing actually can happen when we subtract the same thing from both sides. For example, we start with the 8 equals 8, and we do 8 minus 11 on we do minus 11 on both sides, and that does give us -3 equals -3, which is true. This is called the subtraction property of equality, because we are subtracting the same thing on both sides. Now, because of negatives, The subtraction property of equality and the addition property of equality are nearly the same thing. We can just add the same number to both sides, and we can use negatives if we want. So when solving an equation, the ultimate goal can be thought of several ways. We went over these three things earlier in the video, so I'm just going to skip over that right now. The property, the addition property of equality, you may add the same amount to both sides of an equation. And the subtraction property of equality, you may subtract the same number from both sides of an equation. And then substitution property, okay, this is an important one when we're checking solutions, as well as for other reasons. When two expressions have equal value, one may replace the other. For example, x plus 7, where x equals 3, can be written as 3 plus 7. We just replace the x with the 3 since x equals 3. The substitution property is used to verify a solution. So on page 28 in your notes, consider these two examples. D plus 37 equals negative 5. That's the original equation. We're going to add negative 37 to both sides to create a 0. That's because 37 needs a negative 37 to make 0. And without that, you won't make 0. So when I do that, I get d plus 0 equals negative 42. Over here on this side, we've got negative plus negative. You get a bigger negative, remember, keep the sign. Okay, and then d plus 0 is just d, so we actually get the solution, negative 42. When we verify the solution, we take the original d and we're going to replace it with negative 42. So this original equation, d plus 37 equals negative 5, we've got it right here for checking the solution, except now we're plugging in negative 42 for d, because that's what we found to be the answer. And when we simplify it down, we get negative 5 equals negative 5, which is true. When you try the answer that you got in and you get a true statement, that tells you that you did it correctly. Okay, next example, g minus negative 3 equals 9. G minus negative 3, we're going to add a negative 3 to both sides. By the way, this minus negative, I would probably change it to plus positive 3. And then you see that you were just doing a negative 3 on both sides. Negative 3 and 3 make 0. We end up with g equals 6, that's our answer. And when we take the original equation and plug in 6 for g, 6 minus negative 3, that's the same as 6 plus positive 3. And we do get 9 equals 9. Because it is true, this is the solution. Okay, let's look at a couple more examples. We're going to solve x minus 5 equals negative 1. First, you need to think of, how do I get x by itself? Well, the way we're going to do that is by creating zeros. So the x minus 5, we need to change it so that it is x plus 0. So we need to change this negative 5 into 0. We need to completely get rid of it. So we do that by plus 5. Plus 5 and negative 5 will make 0. So we do that on both sides. And x will equal 4. X plus 0 equals 4. And then because that is our, we do have x by itself, 4 is our solution. Now just checking the solution, we take the original problem, x minus 5 equals negative 1. Let me fix that up a little bit. Equals negative 1. And we're going to replace the x with, 4? So we replace the x with the value we got for x. And 4 minus 5 is negative 1. Negative 1 equals negative 1 is true. So this is the solution. Okay, next example. Z plus 3 halves equals 1 half. We do need to get rid of this 3 halves. You get rid of it by doing the opposite of it. The opposite of 3 halves is a negative 3 halves. If we do negative 3 halves on both sides, we get z by itself. Z plus 0, because yeah, this will be a 0 now. And 1 half minus 3 halves is negative 2 halves. That's negative 1. So z equals -1 is the solution. And then we just need to check the solution. So we take the original equation, z plus 3/2 equals 1/2. We're going to replace the z with -1/2, or -1, sorry. To be able to check this, I do need a common denominator here. So I'm going to go ahead and use a 2. -1 is -2/2 plus 3/2 is supposed to equal 1/2. And this is, since the denominators are all the same, remember you can just do the math on the numerators. -2 plus 3 equals 1. That is true. So this one does check out to be correct.